Hi students, next we are going to see velocity time graph. The previous video we saw about position time graph. Now we are going to see about velocity time graph. Here also we have to draw the graph with respect to two parameters. From the word we can understand what is it? Velocity, the first parameter, and time, the second parameter. Always we take time on x-axis. So take time on x-axis. Time is measured in second, the SI unit. And y-axis we are taking velocity. What is the SI unit of velocity? Meter per second. So take both the parameters. Whatever the data given, take the tabulation. If they have not given you the tabulation, draw the tabulation even if it is 2 or 3 values. Start drawing. Draw the table. Once you draw the table and graph, you will clearly understand how the graph or how to measure the parameter. So it is very easy for you. Here, first thing, we have three types of graphs. The first one is with the constant velocity. So on the x-axis we have taken time, on the y-axis we have taken velocity. See, I have increased the time period by 2 seconds, 0, 2, 4, 6, 5, 10, 15 on y-axis. So I have given the scale like x-axis 1 unit 2 seconds and y-axis 1 unit 5 meter per seconds. So whenever I am increasing the time period, I am increasing from 0 to 2, 2 to 4 and 4 to 6, it keeps on moving and I am keep on increasing the time period. Whenever you increase the time period, what about the velocity? At 0, it is at 15. At 2 also, it is at 15. Then 4 also 15. 6 also 15. So whenever you increase the time period or you are increasing the time period but still there is no variation in the velocity of the object, then it shows the constant velocity graph. The velocity of the vehicle remains constant. So this graph is known as constant velocity. Velocity is not changing with respect to the time, so it's a velocity of the vehicle is constant. Once the velocity remains constant, what happens to the acceleration? This is very important because acceleration is rate of change of variation in the velocity. But velocity is not changing. When the velocity is not changing, the acceleration of the object is 0. Very important. The acceleration of the object is 0 when the velocity remains constant. So this is first graph. Velocity time graph. The first graph is velocity, constant velocity. Next one, increasing velocity. Here also, see the time I have taken 0, 5, 10, 15. I have given 1 unit is equivalent to 5 seconds. So 0, 5, 10, 15. X-axis I have taken time and y-axis I have taken velocity. What is the value? 2.5 meter per second, 5 meter per second and 7.5 meter per second, which is nothing but 1 unit is equivalent to 2.5 meter per second. I have given the unit as like difference 2.5. So what is the increasing velocity? Here with respect to the time, the velocity of the vehicle is keep on increasing. So at 5, it is at 2.5 meter per second. When I increase the time period to 10, the velocity is also increasing, which is 5 meter per second. Next 15, then it reaches 7.5 meter per second. But what is the difference? Here it is increasing velocity, but what is happening? In the equal interval of time, the velocity is also increasing in equal amounts. For example, the first difference between these two, if it is 5 seconds, the difference is giving 5 seconds. What is the difference in the velocity? 2.5 minus 0, which is nothing but 2.5 meter per second. Second case, what is the difference between T2 minus T1? Again it is 5 seconds. What is the difference here? 5 minus 2.5, which is nothing but 2.5 meter per second. Take the third case, 15 minus 10, which is nothing but here 5 seconds. What happens here? 7.5 minus 5, which is again 2.5 meter per second. So equal interval of time, if you are measuring the velocity is also increasing by equal amounts. This is what it shows. Acceleration is constant. What it shows? Acceleration is constant. So what it shows? The acceleration is constant. Whenever the acceleration is constant, we have to check what is the direction of the vehicle. Means the direction of acceleration in this case, it moves with respect to the velocity. So acceleration is constant, but it takes the direction of the velocity. Hi students, the third graph, which is velocity time graph, third graph, decreasing velocity. So the decreasing velocity, see the same graph I have duplicated, I have taken with respect to the decreasing velocity. The time interval 0, 5, 10, 50, but here 2.55, the same difference, 2.55, 7.5, here also 2.55, 7.5, but I have taken decreasing velocity. See at 0, what is the velocity of the vehicle? It is 7.5 meter per second. So at 0, it is 7.5 meter per second. Then when the time is increasing, what happens to the velocity? It starts decreasing. It starts decreasing. At 0, it is at 7.5. At 5, it is the 5 meter per second velocity. 10, it is 2.5 meter per second. Then 15, it is 0. So if you see, for each and every 5 seconds, it is decreasing by 2.5 meter per second. If you see 0 to 5, what is the difference? 5 seconds. First 5 seconds. What is the change in the velocity? 7.5 minus 5, which is nothing but which leads to decrease 2.5 meter per seconds velocity. The second time slot, 10 minus 5, that is 5 seconds. Next 5 seconds, what is happening? It is moving from 5 to 2.5. If you see the graph, which is nothing but again 2.5 meter per second. Then third time difference, 15 minus 10. The third difference, 5 seconds also, it went from 2.5 to 0, which again gives 2.5 meter per seconds velocity. So what is the difference? Here also it is 2.5 meter per seconds in each and every cases. Here also it is 2.5 meter per seconds. But what happened? Whenever there is a change in the time period, equal interval of time period, if I am taking also, the velocity gives equal amounts, but it is decreasing value. What it shows? It shows decreasing value. That's why this graph is decreasing velocity graph. And remember one thing, nowhere it is like we have to take always the constant slope. It is not like that. It may give you the variation, like the increasing can be like this also. The decreasing can be this also, means curved one. We can expect those type of questions also. In that case, what is one? The difference is not a constant value always. Only that we have to take care. And here what happened to the acceleration? Velocity is decreasing, but the acceleration remains constant because each and every case gives you the same velocity, which is nothing but your 2.5 meter per second. It is decreasing velocity. From the graph we can understand very easily that it is decreasing velocity. The acceleration remains constant, but it is retardation. Retardation is nothing but your acceleration, means the vehicle goes in the reverse way. The velocity is decreasing, or it went to brake is applied, so the velocity is decreasing. It can be of any case also. So just go through all the graphs and don't take only the constant value, you have to take the variation, means curve also you have to go through. Thank you.